So what is a mole? I know the first time I was dealing with moles in chemistry, I really didn't understand it, and it seemed pretty scary. But what is a mole? A mole is simply a unit of measure. It's very similar to a dozen. And a dozen, everyone knows what a dozen is, and a dozen is not scary. And neither is the mole. So let's figure out what exactly it is. 1 dozen equals 12, right? 1 dozen eggs equals 12 eggs. 1 dozen cats equals 12 cats. So what do we see between these two? We see that eggs and cats are interchangeable. So the important thing about the dozen is that it refers to a number, and that number is 12. What else can we do with the dozen? We can do unit conversion with the dozen. Here's an example. Let's say you have 36 eggs. Well, we know that 1 dozen eggs is equal to 12 eggs. This fraction here is equal to 1, because 12 eggs equals 1 dozen eggs. So if we cancel out eggs, what we find is that 36 divided by 12 is 3 dozen eggs. And we know that's true. 36 eggs is 36 eggs is 3 dozen eggs. So like a dozen, the mole is a number, and we can do unit conversion with it just as easily as with a dozen. So that wasn't scary, right? We know a dozen represents 12, and we can have 1 dozen eggs, 1 dozen cats, and we can convert using that. So we're going to go through the same exercise with the mole and see that it's not scary either. So 1 mole is equal to 6.022 times 10 to the 23rd. Things. And what can we have a mole of? We can have 1 mole of atoms. And what does that mean? 6.022 times 10 to the 23rd atoms. We could have 1 mole of molecules of water. And that means we have 6.022 times 10 to the 23rd molecules of water. Right? Just like we saw with dozen. Atoms, molecules, are not what make a mole. What makes a mole is this number. And this number is a special number. It's called Avogadro's number, represented by n subscript a. And Avogadro's number is 6.022 times 10 to the 23rd. It doesn't have any units. It's a number. So a mole of things equals a certain number of things. And that certain number is Avogadro's number. So again, 1 mole of things is a certain number of things. And that certain number of things is Avogadro's number. And if you're at all familiar with the periodic table, you will recognize that you're actually very familiar with the mole and Avogadro's number as well. So if we look at what's under the name on this periodic table, we have the atomic mass. So let's look at the atomic mass of boron. So boron has a relative atomic mass of 10.811. The relative atomic mass of an element on the periodic table is equal to the mass in grams of an Avogadro's number of atoms, or 1 mole of atoms, of that element. So let's work through this. 1 mole of boron atoms is equal to an Avogadro's number of boron atoms. So that's 6.022 times 10 to the 23rd boron atoms. And from the periodic table, we can see that 10.811 is the relative atomic mass of boron, and that means that 1 mole of boron atoms is equal to 10.811 grams of boron atoms. So it's all interconnected. The relative atomic mass shown on the periodic table is the mass in grams of an Avogadro's number of atoms of that element. Super useful, super helpful. Let's go over an example. So just like a dozen, let's do a simple unit conversion with Avogadro's number. Let's say we have 18 grams of water. Let's convert that into moles. So for unit conversion, we're multiplying by a fraction that is equivalent to 1. And here we want moles in the numerator and grams water in the denominator. So how many grams of water are in a mole of water? Well, we know from the periodic table that the relative atomic mass listed on the periodic table is equal for each element to 1 mole of those atoms of that element. So for a molecule, we add up the relative atomic masses for the different atoms that compose that molecule. So in 1 mole of water, we have 18 grams of water approximately. So 18 grams of water is 1 mole of water. Simple. Let's say we have 24 grams of carbon atoms. Let's convert this into moles. 24 grams of carbon atoms will multiply by a fraction equal to 1. We want moles carbon atoms, and we're trying to get rid of grams carbon atoms. So how many grams of carbon atoms are in 1 mole of carbon atoms? We look at the periodic table at the relative atomic mass. We know that there are 12 grams of carbon atoms in 1 mole of carbon atoms, because what's shown on the periodic table is the mass in grams of an Avogadro's number, or 1 mole, of atoms of that element. So we know that 24 grams of carbon atoms is 2 moles of carbon atoms.